Let's practice solving some absolute value equations together. Now, keep in mind that absolute value just represents the distance of a value from 0. So when we do each of these problems, there may be more than one solution because two numbers could be the same distance away from 0. So let's get right into it. For number 1, we have the absolute value of x is equal to 3. So what is that really asking? It's asking what value of x would be 3 units away from 0. Now, there are two cases that this is going to happen. So what we're going to do is we're going to write one equation where we just ignore the absolute value bars and just write x is equal to 3. And there's going to be another scenario where we're just going to go ahead and write that x is equal to the opposite, and we're going to say the opposite of 3 is negative 3. So in this particular case here, we have two solutions. We have x is equal to 3 and x is equal to negative 3, right? Both of these numbers are 3 away from 0, so this makes sense. I'm just going to go ahead and write my solutions here in set notation. I'm going to say that x can be equal to negative 3 or positive 3. These would be the two solutions that would make sense here. Let's try another very similar one. So in this case, they're saying the absolute value of x is equal to 8. So the distance that x is from 0 has to be 8 units. So just like before, let's go ahead and get rid of the absolute value bars and just say that x is equal to 8. That's always going to be one equation where you just drop the absolute value bars. The second version is going to be saying x is equal to, or whatever's inside the absolute value bars, is equal to the opposite of what's on the other side, which is negative 8. So both of these numbers, 8 and negative 8, are indeed 8 away from 0. So hopefully that makes sense. In set notation here, we can say that x is equal to, and the two numbers that make this true are negative 8 and positive 8. Here's a third example. In number 3, we have the absolute value of x plus 5 is equal to 9. So the sum of these two numbers must be 9 away from 0. So let's go ahead and write one scenario. One scenario would be x plus 5 is equal to 9. Just drop those absolute value bars. The other scenario would be that x plus 5 would be equal to negative 9, right? Because if it equaled negative 9, then the absolute value of negative 9 would be positive 9. So let's go ahead and solve each of these one-step equations. On the equation to the left, we can go ahead and subtract 5 from both sides. If we do so, we're going to end up with x is equal to 4. And for the equation on the right, we're also going to take away 5 from both sides of the equation. If we go ahead and do that, we're going to get that x is equal to negative 14. So in both of these scenarios, this should work. If x was 4 here, then 4 plus 5 would be 9. The absolute value of 9 is indeed equal to 9. And if we plug in this x equals negative 14, negative 14 plus 5 is negative 9, and the absolute value of negative 9 is indeed 9. So there's two numbers that make this equation true. The first one is going to be this negative 14, and the second one is going to be this positive 4. These are the two solutions to this equation. Here's number 4. In number 4, we have the absolute value of this x minus 3, or the difference of x and 3 is equal to 7. So one scenario is going to be just dropping the absolute value bars. Let's just say x minus 3 is equal to 7. And in the second scenario here, we're going to say that x minus 3 is going to be equal to the opposite of 7, or negative 7. Now, as you get used to these, you're going to notice that the property of equality is going to be the same here for both. So I'm going to go ahead and add 3 to both sides of the equation, but I'm just going to go ahead and do it right away for both equations. So hopefully that's okay. If not, you can just do one at a time. On the left side here, we're going to get that x is equal to positive 10. On the right equation, we're going to get that x is equal to negative 4. So feel free to pause the video if you want to plug these values into the original absolute value equation to see if it is true. And otherwise, I'm just going to say in set notation that x is going to be equal to two solutions here. We have negative 4 and positive 10. These would be the two possible solutions here. All right. Let's move on to number 5. For number 5, we have the absolute value of 2x minus 5 is equal to 11. So here we have a more complicated expression inside the absolute value bars, but basically this 2x minus 5, if we can make it equal 11, then this would be true. Or if we can make this 2x minus 5 equal to negative 11, then this equation would be also true. All right, so we have two-step equations. Let's start by adding 5 to both sides of the equation on the left. Let's go ahead and just write it on both sides of the equation for the equation on the right if you would like to. All right. So if we go ahead and do that, the equation on the left, we're going to get 2x is equal to 16. And for the equation on the right, we're going to get 2x is equal to negative 6. Next, we're going to go ahead and divide both sides by 2. And we're going to go ahead and do that to both sides of both equations here. On the equation to the left, we're going to get x is equal to positive 8. And for the equation on the right, we're going to get x is equal to negative 3. So these are going to be our two solutions. Our first one that would work here is x equals negative 3, or a smaller solution, and our greater solution is going to be x equals positive 8. And just to be clear that this does work, we can take this 8 and plug it in. So 2 times 8 is 16. 16 minus 5 is 11. The absolute value of 11 is going to be 11. Using this solution over here, 2 times negative 3 is negative 6. Negative 6 minus 5 is negative 11. And negative 11 is indeed 11 away from 0. So this checks out. For number 6, we have the absolute value of 2x plus 7 is equal to 13. So let's see, if we can make this 2x plus 7 equal 13, then this would be good. That would be one of our solutions if we could find out x. And if we could make this 2x plus 7 equal to negative 13, or get the inside of the absolute value bars to equal negative 13, that would also help us find a solution. So our first POE, or property of equality, is going to be subtracting 7 from both sides. Let's go ahead and do that to both of these equations. If we go ahead and do that, the equation on the left, we're going to get 2x is equal to 6. And for the equation on the right, we're going to get 2x is equal to negative 20. Next, let's go ahead and divide both sides by 2, and we can do this for both of these equations. If we go ahead and do that, then the equation on the left, we're going to get x is equal to 3. That'll be one solution. And the equation on the right will get x is equal to negative 10. So for this particular equation, we have two solutions. The first one's going to be negative 10. And the second one is going to be positive 3. Those are our two solutions. Here is number 7. In number 7, we have the absolute value of 3x minus 9 is equal to 12. So let's go ahead and write two scenarios. So we have 3x minus 9. If we can make the inside of this absolute value bar equal 12, that'll be good to help us find a solution. And if we can make it equal negative 12, that'll be another way to find a solution here. All right, so for the equation on the left, let's go ahead and add 9 to both sides so we can isolate x. But for the equation on the right, let's go ahead and do the same exact thing. All right, so let's go ahead and add 9 to both sides here. So for the equation on the left, we're going to get 3x is equal to, and we're going to get 21. And on the equation to the right, we're going to get 3x is equal to, and I think we're going to get negative 3 here. For both of these equations, go ahead and divide both sides by 3. Using that division property of equality. And if we do that, we're going to get that x is equal to 7 for the equation on the left, and that x is equal to negative 1 for the equation on the right. So our two solutions here are going to be negative 1 and positive 7. For number 8, we have the absolute value of this 4x plus 12 is equal to 20. So let's see, in one scenario for this to be true, 4x plus 12, if we can get it to equal 20, then that'll help us find a solution. And then if we can get this 4x plus 12 here to equal negative 20, that'll also help us find a solution. So let's go ahead and subtract 12 from both sides of the equation. Let's do that for both of these, since it seems to be the similar pattern here. Let's go ahead and see what that's going to get us. On the equation to the left, we're going to get 4x is equal to, looks like 8 on the right side. And then for this equation on the right side, or in this scenario, we're going to get 4x is equal to negative 32. All right, next let's go ahead and solve these one-step equations to get the coefficients to be equal to 1. So we can do that by dividing both sides by 4. If we do that, we're going to get x is equal to 2, and x is equal to negative 8. So putting this all together, we have two solutions to this absolute value equation. We have x is negative 8 and x is equal to positive 2. Two good solutions here. For number 9, we have the absolute value of negative 3x minus 6 is equal to 15. So let's see, in scenario 1, let's get this inside expression of the absolute value to equal 15. That'll be good. Our second scenario is negative 3x minus 6. If we can get it to equal negative 15, that'll also work. So let's go ahead and start by adding 6 to both sides of these equations so that we can isolate x. Alrighty, so if we do that, we're going to get negative 3x is equal to 21 for the equation on the left. And for the equation on the right, we're going to get negative 3x is equal to negative 9. In both cases, we have a one-step equation. Let's go ahead and divide both sides of these equations by negative 3. That way the coefficient for x is going to be positive 1. So if we do that, we're going to get x is equal to negative 7, and that x is equal to positive 3. So these are going to be our two solutions. We have negative 7. That would make this equation true. And if x was 3, that would also make this equation true. Here's number 10. In number 10, we have the absolute value of negative 6x plus 18 is equal to 12. So in this first scenario, let's see if we can get this negative 6x plus 18 to equal 12. That'll be good. And for another scenario, if we can get this negative 6x plus 18 to be equal to negative 12, that will also be good. So let's go ahead and subtract 18 from both sides of these equations. Let's do that for both of them. And so if we go ahead and do that, for the equation on the left, we're going to get negative 6x is equal to negative 6. And for the equation on the right, we're going to get negative 6x is equal to negative 30. Let's go ahead and divide this left side equation by negative 6 on both sides and do that to the same thing for the equation on the right. That way we get our coefficient of x to be 1. On the left side here, we get x is equal to positive 1. And over here to the right, we get x is equal to positive 5. So our two solutions here, x is going to be equal to 1 or 5. These would be two solutions. For number 11, we have the absolute value of 8 plus 2x is equal to 10. So in order for this to be true, this 8 plus 2x would either have to equal positive 10, or this 8 plus 2x would have to equal negative 10. So let's go ahead and solve each of these two-step equations. For the equation on the left, let's go ahead and subtract 8 from both sides, and let's do that for the equation on the right as well. Now if we go ahead and do that, for the equation on the left, we're going to be left with 2x is equal to 2. And for the equation on the right, we're going to get 2x is equal to negative 18. All right, for each of these equations now, let's go ahead and divide both sides by 2. That way we can get the coefficient of x to be 1. On the left equation, we're going to get x is equal to positive 1. And for our other equation, we get x is equal to negative 9. So these would be our two solutions. X could either equal negative 9 to make this equation true, or x could equal positive 1. All right, here is one final example. We have the absolute value of negative 10 plus 5x is equal to 20. For this to be true, in one scenario, negative 10 plus 5x could equal 20, but it could also equal negative 20. All right, so let's go ahead and solve each of these scenarios to find out our possible values for x. So to get x alone, let's go ahead and start by adding 10 to both sides of this equation, but let's go ahead and do that to both of these two-step equations. If we go ahead and do that to both sides, for the equation on the left, we're going to end up with 5x is equal to 30. And for the equation on the right, we're going to get 5x is equal to negative 10. Next, let's go ahead and divide both sides by 5. Let's do that for both equations. And we're going to find out that 1x, or just x, is equal to 6, or 1x, or x is equal to negative 2. So our final two solutions here are going to be x is equal to negative 2 or positive 6. And so putting this together, our two solutions here for this equation are going to be x equals negative 2 or positive 6. All right, so there you have 12 different examples of solving some absolute value equations. Now keep in mind, all these came out to pretty nice numbers. There were no fractions or decimals, and that was designed on purpose, but you can get fractions and decimals, and they do get more complicated. Also keep in mind that sometimes you could have one solution if it's equal to 0 on the right side or on the side that doesn't have the absolute value bar, or you could have no solution if it's equal to a negative number, but we'll get into those in some future practice problem sets. So if you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.